It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Finding Doing Nice Coffee.
Hi guys, welcome to this video which is going to be all about some of the effects upon equilibrium positions, referring to Le Chatelier's principle. So if you haven't already done it, I suggest you go back and have a look at the video on Le Chatelier's principle. Make sure you've got it in your head, that you understand what it means, that a system will counteract a change imposed upon it, and that you kind of just really have a good understanding of that before you jump into these ones as we look at the graphing. So there's three factors that can affect the position of an equilibrium that we're going to be looking at through graphing, and the first one we're going to be looking at is concentration. Okay, so what I'm going to do is I'm going to try and colour code my equation here, and also colour code the graph to be able to make it a bit easier for you to follow. So the first reaction that we're going to be looking at is the reaction between sulfur dioxide and oxygen gas to give us sulfur trioxide. Okay, so we're going to start off with some sulfur dioxide. We need 2 moles of sulfur dioxide. We're going to add that to some oxygen. Okay, so we need 1 mole of oxygen. That's going to form an equilibrium with sulfur trioxide. Okay, so we need 2 moles of our sulfur trioxide, like that. Okay, so using this equation, we're going to look at what happens when we change the concentration of one of the species. Okay, and for this example, what we're going to be doing is we're going to be looking at increasing the concentration of our oxygen. Okay, so this one here, our oxygen, we're going to increase it, and we're going to have a look at what effect that has upon the position of the equilibrium and the graphs when we draw it. So if we're graphing concentration over time, okay, for a reaction, so I'm going to show you this one here. Okay, concentration over time. I'm going to show you how each of the different species changes in their concentration. So initially we have no sulfur trioxide, because the sulfur trioxide is what is made, is the product of the reaction. So initially there's no sulfur trioxide, we've only got sulfur dioxide and oxygen. So initially the concentration of sulfur dioxide is high, okay, which means we have a high rate of reaction because there's lots of successful collisions occurring per unit time. So we have a steep slope to begin with, and then over time that goes towards a horizontal slope or slope of 0, which means that our concentration is constant. We also have some oxygen which reacts as well. Okay, there it is. And because we have high concentrations of those initially, the rate of formation of our sulfur trioxide is fast, and then it slows down, so we get to this point here. Okay, there's our sulfur trioxide. So this is just showing some of our concentrations as we go along. Where we get to a point where we have horizontal slopes for all of them, or a slope of 0, that is where we have established equilibrium. Okay. Now, what we're going to do is looking at what happens at this system if we change something. So if nothing is changed in this system, it will just stay at these same concentrations. The rate of the forward reaction is the same as the rate of the back reaction. There's no change in the macroscopic properties that we can see. But what we're going to do is we're actually going to change the concentration of one of these species, and what we're going to do is we're going to increase the concentration of our oxygen. So what's going to happen is our oxygen concentration straight away is going to jump up. That's the point where we increase the concentration. Now what happens is that the equilibrium will shift to counteract that change. So because we've increased the concentration, the equilibrium is going to shift to want to decrease that. Now we've got 2 reactions that will occur. The forward reaction, where we form SO3 by using up sulfur dioxide and oxygen, and the back reaction, where we form sulfur dioxide and oxygen by using up SO3. Okay? So what that means is if we want to decrease the concentration of oxygen, we need to favour the back reaction. Okay? So our equilibrium shifts to the left, okay? And it shifts to the left in order to decrease the concentration of oxygen. So what that means is our oxygen is now going to decrease, so it's going to go down, okay? Because our oxygen is going down, it must be reacting with sulfur dioxide, so the sulfur dioxide concentration is also going to go down, okay? And it's important to notice the ratio in the equation. It's 2 moles of sulfur dioxide, 1 mole of oxygen. So the sulfur dioxide actually goes down by 2x, okay? And the oxygen goes down by 1x. There, okay? Now, the sulfur trioxide here is being formed, and that's going to go up. So sometimes your graphs can get a little bit messy, but it's going to go up like this, and it's going to go up by 2x amount. okay, up to there. All right. What we get to is a point where the slopes of all the lines are now horizontal, or they're zero, which means we've established a new equilibrium, okay? So where we get to that point through here, okay, that's our new equilibrium over there. It means we've established our new concentrations. Now, the important thing to know during all of this, all right, is that there is no change to Kc, okay? So the equilibrium constant value does not change, okay? It just changes the concentrations we have, but the ratio of them still stays the same, so our equilibrium constant is the same. Obviously, if you're going through this and you want to talk about a decrease in concentration, instead of going up, your line would go down, and then you look at which way the equilibrium shifts, okay? So that's the first one, that's concentration. Like I said, you might want to make sure that you go over this a couple of times. It's really easy to know when a concentration change has occurred because you get one of your species going up or down straight away, okay? And that's unique to concentration. All right, have a look over this a couple of times, then move on to the second video, which will be all about pressure changes. Thanks, guys.